Shake Table Lab by Finn Meisel and Jared Severance. Finn and I first made a blueprint for our building. Because of building codes, we needed both stories to be at least 18 centimeters apart. Before we added any supports, we needed the corners secure and in place. This step is very important because Finn and I wanted a good start and a well-made base. Finn and I now have most of our side supports in. We needed to make quality supports or else our building would fail miserably. Both of us wanted to test our tower to see if it had any weak spots. Also, now we have all our side supports in and are ready for the top layer. Finn and I now are making supports for the top layer. To make the top layer, we need to have supports on the top layer so it does not collapse. Building codes required Finn and I to make both stories combined at least 36 centimeters. We made our first story base bigger than our second story base because we thought it would make our tower a lot stronger. After we finished our tower, we tested it with 4 sandbags. Putting the sandbags on the tower is called static testing, which is what we did. As we were building, we put in supports, which strengthen our building. Finn and I used lots of supports to strengthen our building as much as we could. Our tower has lots of strong parts, but the strongest parts are the 2 straws put together in between floors. The 2 straws are the strongest part because there are 2 straws put together, which makes them extremely strong. One of the weakest parts on our building is one of the connections. The support is off-center and is not straight, which caused it to be very weak. Finn and I put tape in many different spots, including joints and connections. We did this because they were the weakest parts on our tower, and we hoped by using more tape it would strengthen those locations. One of the extra supplies we used was paper. We put paper on both floors so that the sandbags would hold. If the sandbags did not hold, our tower would fail. Currently, our tower is finished and has 14 sandbags on it. Towards the end, our building is about to collapse.
I can smell that major earthquake coming.
No! Stay. 1-0.
The XYZ graph shows how much our tower moved. Green shows the side-to-side motion, as orange shows the forward and backwards. Also, the blue shows how much our tower moved up and down. Hello, my name is Jared Severance. Our building was relatively strong and held 14 sandbags. The location on our building where it failed was the cross pieces. There was not enough tape holding the cross pieces in place, and the cross pieces came out. At that time, it was almost like there were no supports and the building just collapsed. If I was going to do this building over again, I would make sure we had plenty of tape on the cross pieces so that they wouldn't come out. And I would make sure that most of the supports were diagonal. I learned that an earthquake-proof building has a lot to do about supports. The supports on the sides are very important and that you need plenty of them. The supports in the middle are not as important, but they're still important. I love this project because we got to use our creative mind and we got to learn all about building. Thank you.
Hello, my name is Finn Meisel. Our tower successfully held 14 sandbags. Our weakest part, or where the building collapsed, was our first story X pieces. We put too little tape, and then when the tape came undone, it just collapsed. If I could do this project again, I probably would have added more supports on the sides and more of a cone shape for the middle supports. I learned that it doesn't matter as much about the uprights in the middle as much as it matters about the uprights on the side, because one of our friends' buildings had 0 uprights in the middle and tons on the sides, and it works amazing. I love this project because you get to share your creative mind with all your friends, and it was really fun to build a tower and then destroy it. Thank you.